Hey. By some reason I dropped. Or it dropped everyone.
Yeah, it looks like the host end the call. It's like
Okay, no problem. So let me share my screen again. Can you see it now?
Not yet.
Hey, sorry, I think someone ended this meeting by mistake.
No problem. So let's continue.
Yeah. So one question I have is like, we kind of like, drifting away the architecture principle, right? So this status, basically whatever the host service status, like, kind of, we are storing it in, like, we are subscribing to dbus, that is good. But like, we need to capture that in somewhere like, state DB, that would be like, it's good that all other applications should be aware of that.
Yeah, exactly. We are capturing both. We are capturing dbus and we are capturing state DB.
Sounds good.
State DB is used to capture the status of the applications, of the business logic you have. So your business logic you add, it can notify its status through state DB, and the services itself, that like Linux units, you can know its status through the dbus. That's core functionality. That's why I don't want to be focused on that.
So what happened? Let's say if I disable dbus, I think if dbus comes with image, that's fine. For example, let's say a disable dbus feature service, right? So what will happen to this feature?
You won't listen for that particular service. If you will disable dbus, you won't wait for that service at all.
So you don't wait for that service at all?
Yeah.
Okay, so basically, to have this system ready feature, dbus is the mandatory thing.
Yeah.
Okay.
As part of that feature, yeah, it's mandatory.
Okay.
Can I assume this dbus is used only used for the Linux services, not for the some of the core containers or host config services in the SONiC?
Correct.
Okay, all right.
Okay, let's continue. So subtask in sysmonitor, what was added here? The subtask, I add new subtask. It's a timeout. So timeout can be configured through platforms system health monitoring config.json. I will show that file in a minute, by timeout field in that file. Right now, that feature is using that file to get ignored services. So I just extend it with the needed functionality like timeout. By default, timeout is 10 minutes. And once the timeout is passed, sysmonitor will write down to the state DB as a system status. Right now, current functionality that exists today in SONiC can wait indefinitely, but if I present a timeout in order to not to wait indefinitely, because you may want to notify some services much earlier that the system is down, so you don't need to wait more time. And timeout can be, since that file is per platform. What? I don't get it.
I guess to hear some noise.
Yeah, some noise. You can continue. Yeah.
Okay, no problem. Okay, the service identification. The feature today use feature table of config.db in order to get the status, the list of services it wants to wait for. What was added in terms of that functionality?
I just have a quick question here.
Yes.
So here, right, if it is a system-based service, the system-based service already has a timeout, right? So that is one timeout. And anyway, after that, it will be down, or depending on the service configuration, it will restart, right? Do we really need an additional timeout for this? Or is this timeout for the up status?
No, it's a timeout for up
exactly
status. It's timeout for up status. It's not timeout per service. It's timeout for up status. So
for up status. Okay.
yeah. System. Let's say that timeout will force system. I like force in quotes. Yeah, force system to report its status during that timeout. So if system didn't report any status during that timeout, it will report down. So the system is down if it didn't report it. So you can make that timeout whatever you like 1 hour, but by default is 10 minutes. Okay, and additionally, yeah.
I mean, what happens when it restarts or it updates the up status later, right? So from system ready status point of view, you will never declare it up. You will always say it is down because there was a timeout.
Yeah, it will happen exactly like that. If a system didn't report its status during that timeout time, it will report down. That's it. It's permanent state. Usually it shouldn't happen like that, right? Because it happened due to some condition, and we need to investigate that condition. But eventually we will know that. We will know because, for example, system reports every time it reports up status, and now by some reason it reports down status. Why it reports down status? That's a good question. That's a question to investigate, and at least we know that happened, and we can investigate it and try to resolve that problem. That's resolution can be different. For example, we have some bug, we have some inconsistency between the service dependency, or we have just some we need our system is slow and we need to increase that timeout to 15 minutes, let's say.
So I have a question. You seem to mention this state to be permanent. And why the system really state is permanent? Like it sounds to me like once you publish a state, you will never change it. Is that what you mean by permanent?
Yes, exactly.
Okay, so maybe this part I didn't understand. So for example, if initially one service failed to start and you mark the system state as down, but later if someone fixed that service, we still mark the system to be ready as down, or? Yeah,
it will be down anyway. That's because we have functionality that tracks health of the services. It's system health. That's a functionality that tracks all the health of those services. So you can know all the health of your system, whole health of your system by that functionality. But
I mean, let's say SMB service or whatever service. But if the people fix that, it becomes up. But the whole system state is still marked as down. This part I don't understand.
Yes, it will be marked as down. Yeah.
Yeah, but we fixed that particular.
But the thing is, it doesn't reflect the exact state, right? There is now a discrepancy between the actual service state and what system ready is showing.
No. It reflects the state. That functionality is actually 100% used at the boot time. It used for boot to make some boot sequences. Like as I mentioned, you have like a SNMP or some business logic application that expect to be running once a system declares some status, up, down, failed, whatever. So once it declares some status, it can continue execution. That's why you don't need to take care of other states except the one you just declared. If you declare down, that means you need to investigate why it's down. It's down because of something is failed. Why it's failed? The problem. We need to find that problem, why it's down or why it's failed, and fix that problem. Then it will be up, so it won't be down anymore. The same for fail. save
So
for
which
up.
means it's not permanent. Basically, if you fix the, the reason
Yeah,
for the,
of course.
Okay.
If you fix, if it's not permanent, it's in Redis. So the next time you will boot, the status will be up.
Oh, okay, but I don't understand why you boot, then but let's say, AWS has failed, right? So then
Yes.
you mark it down, but later we fix the problem with WSS. We
How you
don't
fix
have
the
to
problem?
reboot the system
No.
to set the system ready to be up, right? So because you fix the problem, then the SMP can be running.
Okay, that depends how you fix that problem. You fix that problem on the switch directly on the boot time, or you fixed it, then reboot, like fixed it in the code, then upgrade to another image, then boot it again, and
No, I just, for whatever reason, there's a bug I fix it. I make the system, I make SWSA to be running again, right? So, and
so
in that case,
so
the
it's not
system is
it's not expected
system
condition.
really should be up, right? So,
It's not expected condition. Why it should be up? It should be failed. It should be failed because originally SWSS failed, so it's a problem. It's not something that, okay, the system is booted, now it declare failed state, failed or down state because of SWSS is not ready, is not started. Then you just manually.
it wasn't ready, right? So it wasn't ready, but later we fixed the problem. Now the system should be ready, so the SMP should be started.
Exactly for that situation, you have system health. You have system health. You can dump the health of all the services, and you can know that like system health now system is healthy, but the event which is used to notify other services is already declared. So that means that you already declare that system is down because of any condition. Why you need to change it? System is down.
I don't get this, right? So I saw the system really is really used for some dependent service to decide whether they can be started or not, right? So if the system is not ready, some of the dependent service will not be started because they think the system is not ready.
Mhm.
But for whatever reason, initially, maybe some core service is failing, so the system is not ready, so the downstream services is not started. But now, for whatever means we take to fix those fix those core services, now the system becomes ready, and then automatically those services, downstream services, should be started, right? So it should, because I think if I understand, the system D also have such similar concept of system ready or not, and it is repairable, meaning that if you fix some of the system, make it running, then the whole system D service will think the system is ready. It's not like it's not fixable, right? So, but it sounds like what you're saying, that this is not fixable,
Okay, I got it. So now imagine you have you are waiting for that event. You're waiting for that event, and you got system is ready. Okay, you got event system is ready, and now by some reason some of the daemon is failed. That's you don't expect to get system is not ready or system is down after that. It's not system health. It's system. That event is used to on the boot, not as the health. We have health HLD. We have health functionality for the system, and using the health functionality, we can investigate if it's if the system is healthy in some like life cycle stage. But on the boot time, you need to know if your service should start or not. So once you receive event, up, down, failed, your service can start and take any action into consideration, what it should be done later on. Depends on the event it just received. But what will happen, for example, if your service started, because one second, I need just 30 seconds. Sorry, I'm here. So you start your service, for example, expect for some event, it receive event, it receive up event, and then how your service should take care of down event or failed event. It shouldn't. It already receive up event. That means that it can move forward. But then if it will receive down event, it's a problem.
No, okay, no, I don't think that's a problem, right? So I think then it's up to application to decide what to react, yes, yeah. I mean, I think the system ready state should be reflecting to the current, should be by definition say, okay, if we say, okay, system ready means that, okay, this call services, this 5 or 6 services, they are ready. Then the system ready state should be reflecting that over the whole switch uptime. And if any service is down, then the system really should be reporting down or degraded state. And the dependent services, the downstream services should be, should be notified whether it's up or it's down, and then they should have their behavior to decide how to react to it. That will make the system more robust, right? So instead of saying, the system really is one-time thing, only during the boot, if everything goes well, so we mark it ready, and after that, it's always mark it ready. Or it doesn't goes well, we mark it down, and it'll never become ready. Right. So
Yeah.
I think, what you're saying, yes, if initially becomes up, later it becomes down, then how should other services react to it? But sure, other services should define its own behavior to react it. But as a framework, when we tell the other services how to use it, how to use the system ready, we should define a behavior where it actually reflect the system ready state, so that based on this framework they can design their behavior, how to react to it, right? So maybe currently they cannot react to the down event, but that's their problem, right? So as a framework we should be more robust, reflecting the current system ready state. It should not be permanent.
I disagree actually, because for example, system ready functionality prints to every user on screen that system is ready. Now imagine you have like the daemon that is failing continuously, starting and then failing, starting and then failing, and you will be, that will spread those events on your screen. System is ready, system is not ready, system is ready, system is not ready, and so on and so forth. It will be a mess. So I think it's that's
for that kind of thing, there is a damping that to remove that. That's a different problem. It's like, okay, a system is oscillating between up and down, then you should have some we should have some damping system to damp it, right? So, but it should not only reflecting the booting status. I mean, if you look at the system D, there's a system ready as well. And if you look at their design, it's always reflecting the current state. It's not like saying, okay, it's up and then it will be always up. If you kill one services, you will become degraded state, and if you fix that, it will become an up state. I mean,
okay.
Think about the downstream services want to know actually the call services state, right? So then they can react. If indeed, for example, some downstream services cannot tolerate some call services to be down, then they should know it. Then they should react to it. But when we design the framework, we should be, have a very how do I say this, more a behavior that is allowed people to do easier reasoning, right? So by easier reasoning means that they know this behavior is is simple, right? So because if we define the system state to be ready when all the call service is ready, but it's not ready when the call service is not ready, then that's a behavior that the other people can easily reasoning about and then decide what they should do about it, right? So instead of saying, okay, because if we just say this is only the initial state to allow the service to boot up, I feel it's like an incomplete.
Okay, basically what I think like as a resolution for that, maybe we can have by default it will be exactly that it is today, but we can have some flag or some configuration that will make the behavior that I expect from that feature, because I don't want, for example, to take care of like all the next stages. I would like to wait for that event. And once I receive any event, down, failed, up, I can continue execution of my feature and then make a decision depend on the event I received. But if we want to preserve the behavior that we have today as part of that feature, we can have, maybe I can propose adding a flag which will allow you to control that. For example, like you can change the system status, or the system status will be permanent. What do you think about that?
Yeah, I mean, if that's a current behavior, then I'm fine. You know, we take another step to correct that behavior.
Okay, got it.
Yeah, but maybe we need to understand why exactly your changes, right? So
actually, my changes.
Right. Your changing would cause a problem because maybe they designed these permanent things based on some assumptions, some of the behavior. But if your changes related to that, maybe it will introduce other unexpected behavior.
Okay, got it. So I will extend that piece.
Let me ask this question, right? So what do you expect the downstream service to do? Let me give the two hypothetical scenarios. Why is that if the system boots up, everything looks fine for a moment, and this service determines the system is up and everyone seems to be happy going forward. That's more or less what Gohan was talking about, right? So, and then later if one service get degraded,
Okay.
and then what do you want the downstream dependency service to do in face of this system's this status kind of permanent at up status, right? So if the other service needs to respond, then it needs to be listening to a different service for the change. That is not as convenient as if you have a single point of information to tell the service has changed, the whole system status is no longer okay.
Okay.
Right? So, and another example is that if the system boot up and something's lacking, the service determines the system is having issues. But that might be a timing issue. Let's say, for example, the configuration is not pushed, SLRS is not running, or some service is not running, as later configuration get pushed down. But this service status stuck at the failed status. We don't really need a reboot to clear the status. The same question as the downstream services. They need to listen into a different channel to get the update instead of listening to your service to get the update. It seems to be inconvenient.
Okay, that actually makes sense. We can have like another event like degrade. So for if system declare up and then it, for example, some services failed, it won't declare down because it doesn't make sense, right? For me it doesn't make sense if system declares up and then declares down. In the case that you mentioned, maybe makes more sense when you, for example, declare up, and after we declare up some service is degraded, we can declare from that up state, we can declare degraded state, but not down, because it's not down. It just declare up, so it can't be down anymore.
Sure. Yeah, I'm okay with those intermediate states. Yeah, that's fine.
Okay, got it. Okay, so As part
Just
of
one question. When does the timeout countdown start? When do you start counting for the timeout?
from system boot.
From system boot. Okay. Maybe after kernel boot up.
Okay. Okay, so as part of that feature, I extended system health monitoring config JSON. We introduced two fields, new fields like sys services to wait, services to report app status. Why we need it? Services to wait holds explicit list of services we would like to wait in order to declare system ready state. Today, just use all the services that are part of multi-user target and SONiC target, and also I extended to use a generated folder from that one. Run systemd generated for services such as NTP config, interfaces config, because it's missed today. But if we want to use for like listen for those services in order to declare system ready status, we need to wait for that folder. But that's technical aspect. It's not don't change the functionality of that feature. Just mention it in the HLD that it's important. And we introduced new fields, services to wait, because today we read all of the services from that SONiC target and multi-user target. But what if we don't want to wait for all those services? So in that case, we can define explicit list of the services. In services to wait, for example, we want to wait only for host config D. So we declare like host config D here in that services to wait list, and it will, and our feature will wait only for that service, not all of them, but only for that. And another field is services to report app status, is the list of services that must report its internal application status in order to declare system ready. Okay,
there is already an app status field in the feature table, right?
Yeah. Because
I think
the
it was
feature
meant for that.
The feature, we can't increase feature table because feature table is used for SONiC applications like SyncD, WSS, SONiC app extension applications, and so on. But services to wait and services to report app status is used for host services and host applications.
But okay, but, so are they not in the feature table? Some of these host services.
Why? What do you mean? Why not in the?
I mean, you mean some of the host services are not there in the feature table. Is what you mean?
Yes, like NTP service, NTP config. Let's say NTP config or interfaces config. It's not part of the feature table. It's just the host services that, for example, we want or we don't want to wait for. So we can declare such list of host services using that field.
Okay, so in that case, do you want to converge between this and the feature table upstaters, or you want to keep them separate?
I want to keep them separate.
Kevin, Senthil here.
Yes.
So in this case, right, like what I understand is you will have your own bucket of services which you are focusing on. Okay, instead of focusing on all the services, all the SONiC services, right? That I understand. Okay. Related to this app status, we can actually use the we can actually leverage the same feature table, right? The feature table is not only the Docker services. It is all the services which we are focusing on. As you said, we can also use the same app status flag for the host services as well, instead of introducing a new flag. Like
yes and no. Actually, I separate it. In terms of reporting statuses, I separate them. The reason why I separate them, because we are waiting for feature we are waiting for for that status in system monitor application only. So the system, all those services are for system monitor application, and that's why I create a new table here to report it. Let me show you. For SONiC applications, the table to report status is feature. For daemons application mentioned in services to report app status is service app. So I just have the same table, the same structure of the table, but service app. If you insist, we can have a feature table, but I would like to have that separation, because since we have separation and the configuration level, like we are configuring SONiC app applications, we are featured config table, we will write their status in the feature state DB. And the application is configured through config file or any other source, we will report them into service app. So we will have logical separation. And it won't, like, when, for example, in the future, you would like to go over all the tables, all the fields in the state DB feature table, you know that all those features are part of feature config. You don't expect to see any other applications there, which is not part of the feature table of config DB, right? That's why I would like to separate it, and it will be consistent in the future.
Okay.
Okay. Okay, basically I mentioned here that host daemon marked their app status as true, considered okay. Host daemons marked their status via in state DB as false, considered failed. So once you app status is false, that means that service is failed. And here the system ready disabled flow. That the thing that I mentioned at the beginning, we would like to control that feature state as enabled and disabled. Enabled is the same as that HLD describes, and enabled, but disabled is the next one. So sysmonitor subscribe to config DB. Once it receives port init done, actually it's not port init done, it will receive, I will change it. It will receive okay from SWSS. It writes system is okay. And that's it. That's the whole flow. So it won't wait for everything that is configured. It will wait only for one particular service, which report port init done, and in our case, it's SWSS. Okay. Basically, I think we run out of time. So most probably we need to continue the next session.
Last question, between failed and down, right? I mean, why can't we combine the timeout as part of the failed itself? Do we really need a down state just for the timeout?
Yeah, I think yes, because down means that the system may be like in the good shape, but like it was delayed, or what was like, it maybe eventually it will report its status later on. So it's not really failed. It's down. It's considered as down because it's not yet up. Yeah, and failed means that service is really failed. It can't read some, I don't know, EEPROM or some specific information that must exist in order to be in operable state. So it will be failed.
But as per the original design, right, I think we follow only okay or down, right? And we have a justification. I think there is an extra column describing the failure status, like why the service is down. So from that, we'll be able to derive whether it is like whether the service is really started or it has really failed. So that information will help, right? Because instead of having another field, another flag called failed. So that's where like we came up with okay or down. That's it.
Basically, I don't get what you mean in general.
Okay. Like, so instead of having another flag failed, okay, just how about sticking with okay and down? Okay, and down for down, there is a column. I forgot, one sec. There is a column, show system status detail. If you give, right, it will list down the down reason as well.
Okay.
Okay, so that from that we could derive if the service is if the service is really failed to start or it didn't even start. So that information could be arrived.
Yeah, but that's for services, of course. For services, it can be like okay, not okay, down, whatever. But
Okay.
that what I meant here is for system status, because in you are taking all the status of all the services, and the situation here, like how we can like feel a difference between down and failed. Down can be even with the service in a good shape. So the service is starting, and it's starting for too long. It's not reported. It failed condition. Why it's failed? It's just starting. Right now it's starting, but eventually after some time, that start time cannot be like indefinite. It should be it should be definite. It should be like within 10 minutes, within 30 minutes, within one hour, whatever. So if you don't receive a good flag from that service, means that it's starting, whatever, it's hung or something bad happened, we will declare down status. And if you will explicitly receive failed state from some service, you will declare failed system as failed, because now you exactly know that system is failed.
I don't know. I think we can put all those details in the detail column. I'm not sure. Still not convinced to have a separate state. Anyways.
Which detail column? Like the system, the sys ready monitor don't have a detail column. It just report status, one field, status up or down. That's it. It don't have a detail column. Each service, yeah, it has detail column, but for the system status, we don't have it. We have only one field. It's status. That's it.
All right. Yeah, we'll take a look at the HLD and see. Yeah. Thank you.
Okay.
I'll also like get back on that.
Okay, so how we can continue on it? We will have another session like the next week, because we are pending on another HLD as well, which should be presented today.
Sorry, Andrew, dropped for another meeting. So I think we can continue this talk in the next session. That sounds good. Yeah, in the next session, I think.
I can
Actually,
continue.
we had additional item in the agenda that we should postpone to next week. We plan to have also additional HLD by Sviat from our team. So will you be able to post a new agenda for the next meeting?
Yeah, I think so. I need to talk with Yanzhao. Yeah.
Thanks, Ming.
Okay,
no problem.
so I will continue today with the rest of the stuff. It's not a lot of the things.
How many time do you need? How many time do you need? I mean for this talk.
I think 5 minutes.
Okay, yeah, I think let's finish it today.
Yeah.
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 Thank you.
Yeah. Sorry. Another field that we add as a configuration is to config DB. Basically, config DB changes is irrelevant for sysready. I name it like that. It's a field in feature table. Why we need it? Because when you add a new feature, it will implicitly wait for, it will affect on system ready. The system monitor will wait for that feature, and we can't actually configure it. We don't want to wait for it. Of course, we have configuration file, but for example, what happens if you have some SONiC app extension? So for SONiC app extension, you can edit them dynamically. So in order to control it dynamically, you have irrelevant. I present here a irrel for sysready field in feature table. once that field is set, a sys monitor won't wait for that service and for that feature at all. It won't be that feature won't affect on system ready. So it allows you to control if the current service you just expand your system with is affecting system ready or not. That's simple. So here I add Young model for it. Basically, we have checkup status. Checkup status means that internal Docker application should report its status or not. And irrelevant for sysready means that it will affect on system or not. So, for example, if that flag is true, sysmonitor won't wait for your service at all. And here's the description for it, definition, sysready state from S types. Oh, I made a mistake, it's admin state. Oh no, it's state, so everything is okay here, the state, yeah. True or false. That's it about the configuration. And the next is StateDB changes. StateDB changes I already described. Someone asked a question about it, so I already described it. Daemons application, which mentioned in service to report app status, must report their state in using app status, and the table is service app table of StateDB. Dockerized application reporting their status via feature table. So here I actually conclude both of those terms. For SONiC application, the table is feature. For daemons application mentioned in services to report app status is table. Table is service app. So the schema for those tables are the same. App status, fail reason, and update time. That's basically 3 fields that can be reported by each application. And at the end is an extension of health configuration file. Today we have we have only services to ignore field in the health configuration file, and we use that services to ignore in order to ignore some services on the host. Of course, we can place here Pimon, we can place here another SONiC application, but it can be dynamically expanded. That's why we want irrelevant for sysready in feature. And another fields all that I mentioned as part of that HLD is services to wait, services to report app status, and timeout. So timeout here in minutes can be can set after which time we will declare system down. Services to wait is the list of services we would like to wait for system ready. So it's explicit list, because by default sysmonitor waits for all the services, but we don't want to wait, for example, for all the services, because we can install Nginx, we can install many other services, and they will implicitly affect on system ready, and it's not good. It's not good, and in that case, we can control at least a list of the services we would like to wait explicitly with that field. And another field is services to report app status. Also, I described it already. The service that must report internal status through StateDB. That's it. That's it for that feature.
Okay, thank you. Do we have any other question? Yeah, sounds good. I think we still have another HRD to review next week, right?
Me no, but as Oren mentioned, we need to review another HLD. Yeah,
it's also from NVIDIA, right?
Yes.
Cool.
Yeah. Okay, I got it. Yeah, I will talk with Jianzhao about the next session. Yeah. Thank you.
Thank you.
Yeah.
Have a good day.
Have a nice day. Yeah. Good night. Bye.